Oh, hi. Sorry, Chris Chinnock here. I just had a little problem setting something up here. Give me 1 minute here. Sorry. Okay. Uh, Chris Chinnock here. I'm president of Insight Media, and I'm very pleased to bring this webinar to you and introduce Dr. John Fan, who is the CEO of Copeland Corporation. John, say hello to everyone.
Hi, everybody. Thank you for joining us.
As you know, this series of webinars is it's a 3 series. So we're going to start today with the past and of AR and VR. Then we'll progress to the present, and in a month we will move on to the future webinar, where John's going to talk about his dream smart glasses. So let me start first with a little bit of background. Dr. Fan is the ideal person to discuss these exciting and important topics, as he and his company have been working in this area for 30 years. So to start this webinar, let's talk about his credentials. First, he's a EE graduate from Berkeley, and then got a PhD in applied sciences from Harvard. After that, he was with MIT for 12 years, and then in 1984, he founded Copeland, where he's been the CEO ever since. So I also just learned that he was inducted into the National Academy of Engineering in 2020. This is actually quite a great honor. There are no Nobel Prizes for engineers, so it's kind of a hall of fame. And of the millions of engineers there are out in the world, there are only 23 current US members and 300 international members. So this is quite a prestigious award. So I think he's also well qualified to deliver this series of webinars. So after the presentation, we'll have some time for Q&A. I'll start with a few questions. But remember, since this series is focused on the past, just try and make your questions a little bit more past focused. In other words, what John and Copeland have learned over the last 30 years in this business. We'll have more time for the present questions and future questions as those webinars roll around. This is also being recorded, and so when the webinar is complete, that will transcode, and I will send a link out to all the registered attendees that they can view this video on demand soon after the webinar, and also for those who are not able to attend in person. So with that, I will turn it over to you, John. Take it away.
Thank you, Chris, for such a kind introduction and for organizing the webinar series on AR/VR wearables. It is the coming of smart glasses. The category of smart glasses, like smartphones, actually will impact all of us. This category is very large, it's huge. And the actual journey actually started about 30 years ago, as Chris talked about. We will divide the webinar into 3 sections, as Chris talked about, mentioned earlier. The part 1 to this section, I will really focus on the past. What has it really happened? What have we learned? And it actually result in my basic 5 rules. The part 2 is our analysis of our current very available systems that just come out. Whole bunch of smart eyewears. And this actually gives us a lot of hints for our climb to the summit. We actually have seen the paradigm shift. The last session, the part 3, is where we outline, in my own personal view, how the path to the summit. Innovations are still needed to transition our smartphones to smart eyewears. The next few years will be truly exciting. We're really ready to climb now. So before I start, I really want to tell you and try to convince you, why do we actually need smart glasses? The benefit of a smart eyeglasses, smart eyewear, actually is a lot more than even smartphones. First, of course, is convenience. We want to transition our handheld smart, smartphones into a mobile environment of which is hands-free. Convenience is very important to us. The second one, I think a lot of people probably do not see it, is actually is augmentation with different sensors and other detectors. We can actually enhance and make our human limitations better. We're actually creating a superhumans. This is very important. In the military, we already know our soldiers can see in the dark, see around the corners, can hear things that you and I cannot hear. Finally, is entertainment. With smart glasses, we can actually transport ourselves into a fantasy world. It's very important for sports, for watching movies, watching different worlds. Is another alternative universe. This is bigger than smartphones. It is more than $1 trillion business. That's why so many people have been thinking about how to work on it. It's a very big business opportunity. Another thing you want convenience. Just think about this man. He's walking around. We can relate to that. We always think of different toys and different equipments, devices to carry. Well, what the smart glasses do is going to combine into one device instead of multiple devices to carry. About the Superman or superhumans, this is it. With a smart glass, in a few years or maybe in 10 years, you can actually think like Einstein. You can see much better. You can hear much better. You can know all the knowledge, and also you can live in another world. So basically, the humans are very different with engineering help. We will make ourselves much higher as superhumans using engineering. Okay, we think the life science is too slow. So by doing this, life science can make us live longer, but engineering will make us live better and live well. So how does the eyeglass work? It's basically eyeglasses combine and actually bridge between our physical world and our virtual world. Our physical world is actually analog. It's not digital. So the idea is how to convert the analog world and bring it to a digital world, massage them, process them, transmit it all over the world, and combine it and put it back into an analog world so we can see and hear. So those headsets or eyeglasses, it started with headsets, it will turn into an eyewear, and finally it will turn into regular glass shape. So it will combine this analog world and into our digital world. That is what those glasses are supposed to do. Well, let's take a look at the analog world. We have 5 senses. A human being has 5 senses. The 2 most important senses that are plotted here on the left, the sight and sound. Of course, they have touch and smell and taste, but most important is sound and sight. So the mobile world, we all started about 30 years ago, as we say. The DARPA actually funded us about 30 years ago. They want us to go to a DARPA, want us to get a wearable computer. And they actually funded us $30 million to start the process. So in the process, we quickly to develop funding for LCD micro displays. That was 1990. In 3 years, we actually developed the display. And IBM quickly using our micro display into that little wearable you can see on the left. And then we have another company, Forte, and then a whole bunch of systems are being developed across the 30 years. I will actually detail that a little bit further, pick up some of the examples. In the process of the 30 years, Kopin actually shipped over 35 million displays, micro displays. Okay, next. So let's look at some of our partners in the last 30 years. It started with the IBM, which is on the left. And then, of course, Forte is a company actually formed between Kopin and Forte, actually make virtual reality helmets. Forte is actually an early precursor of VSIC, as you would know. Paul Travers and us developed this Forte VR helmet. In the process, we actually developed quite a lot of systems, all the way through Google Glass, for instance. VSIC has its their AR glasses for enterprise. Fujitsu, Motorola, they all have been working with us using our displays to make different headsets. How about the next one I'll show you? People who are also put out other headsets which are not involved with us, for instance, the one in the Olympus VR headset. I always liked that headset. It came out almost 20 years ago. And it's actually a VR headset. It's done by Olympus, and actually sold over 100,000 units. It was one of the most successful VR headsets I know of. It was invented by a person called Mr. Iba, and now currently Iba is actually a company now after he retired from Olympus. Sony also come out with the VR who connect to their PlayStations, called VR headsets, and so on and so on. Those are all the headsets previously done. And then at the bottom, we have Oculus and HTC VR. These are the early models, and we will talk about present models to the next sessions. But those are the ones, the North and Snap cameras, those are no longer now available. So we also have therefore we have very limited success. Really, what happened? Why is that so little success and so much disappointment and frustrations in the 30 years? Let's study the past to find what happened. Maybe we can actually find the future. So this is what I think. I think we're just too ambitious. We try to once put the smartphone on our head in one jump. That was too fast. The second thing was happening is we try to immediately get into consumer applications. Like big radical disruptions usually started from military first, go to enterprise, and go to consumer. And I will describe that a little bit later too. So for radical transformation, especially for consumers, we really should keep it very simple and stupid in some way. So we call it stupid. Yes. It's actually very interesting. We did not know that in the 30 years ago. We actually need smartphones before we can go to smart glasses. There is a path that around 30 years ago we did not know. So smartphones actually develop many, many different technology and components which are very useful for smart glasses. Okay. In this case, we're actually Kopin also involved with the smartphones. As many of you, the listeners may know, we actually developed the HBT transistors, which for the smartphone, to make smartphones to be very efficient, low power consumptions. And now the HBT transistors that we developed is every current smartphone that you use. Smartphones really give us a lot of capabilities, abilities, and I won't go into all details, especially with now 5Gs, AI, and big data. This is very, very useful. Now all we need to do is see we can move the smartphone to our person. So be hands-free And then, of course, you can enhance additional things on top of it. So let's look at the disruptive innovations. This is actually a graph come out from Clayton Christensen. He's a professor of Harvard Business School. Unfortunately, he passed away last year. It's a very important curve. If you look at that, if you the upper graph is a smartphone. Smartphones keep on improving the performance with time. What you really want to do is disrupt it, so that's become smart glasses, so you don't have to carry in your hand. But once you do that, the idea is not to one shot put the phone into a glass. It's actually reduce your performance because you already disrupted anyway into a hands-free. So you see the vertical line. You should go down the performance. And then once you go to a new platform, you can keep on improving the performance. And sooner or later, in a decade perhaps, the smartphone will become smart glass. And then when the smart glass will continue improve its own performance. And that curve is the correct one. All these years, everybody look at this curve and we recognize it is exactly what should be happening. So we should really what we need to do is very clear now. What we need to do is put all the human senses onto all the major human senses are on the head. So the platform we need is really put on the is something around your eyes and ears. So best to be on the head. Okay. So the idea is the platform we need is actually an eyeglass. But it's a big problem though. Humans really do not want to wear anything on their head. So we must deliver some value so people will wear. Let's look at what people wear. Okay, people have many things actually people do put on their head. Smart glasses, safety glass, sunglasses, helmets, hats. And what happened is, let's look at the middle one. 40% of the people in the world actually have vision corrected glass. 40%. So this is the platform we should put on the head, is on the glass, on the eyeglasses. So if you do that, so let's look at that. What will you do first? Remember, when you do a transformation, it's already known. First thing you need to do is you need to get a hardware platform that everybody can live on. Then you build operating software on top. Where the operating software works, then you can put the applications. This is exactly how iPhone started, cell phones. Cell phones start have a platform of the iPhone, and then you build operating systems on top of it and the applications. For smart glass or smart helmet, the, the platform we know it should be a smart glass, eyeglasses. Now you know this is your hardware platform. What are the basic rules to build such a smart glass? So I'm going to talk about these basic rules. Rule number one, I actually presented these rules about 2 years ago at MIT Forum. So the first one is human first. To put the eyeglass together, the eyeglass comes first before you combine the technology of the cell phone, technology of the computer, and all the other devices you carry, you combine into eyeglass. It's very important. The eyeglass is important first. So you have to be comfortable. You have to be convenient to use. You have to be very fashionable. You have to be lightweight. You're going to be cost effective that you will wear. That is key. The platform for smart glass is actually eyeglass. It's different, it's the same, it's very different from a smartphone. The second rule is, I think this is Hollywood like you to believe. You get all this data in front of your eye, in your glasses. That is overwhelming. The virtual world should not overwhelm our physical world in the edge in those smart glasses because people get confused. The brain cannot take with all this data. Even the military soldiers and pilots cannot do it. The third rule is very important. I think some of the virtual reality glasses block everything around you. So you do not, you don't have a situation awareness what's happening to you. Humans are not like that. Humans have their own physical sphere of awareness. If you don't have that physical circle, in 10 minutes, you will have to get very nervous and you will take it off. So you have to figure out how you take care of the physical situation awareness that every human needs. This is actually a very important rule. You look at it on the left, a cell phone has a very interesting touch screen. It's actually a perfect input and output for a cell phone. You can navigate and also punch in the data, and you also can see the data. Now, in your wearable glass, how you could do that? You're not going to wear this big screen on your head. That's what happened at the beginning on some of the virtual reality helmets. You put the whole screen on your head, the cell phone screen. That is not going to do it. So I think the first thing we need to do is to understand the input should be voice. Voice is really the new touch. You can hear and can speak many times faster than you can type and read. So this voice should therefore should be the first thing that augmented a smart glass. And that's what we have done wrong. When we start doing smart glass, the first thing we try to do is put the vision in there. And the vision doesn't give us the input output. So you should be voice first. And that's one of the things we learned very in the last in the last few years. And the final rule is what I already showed you about the Clayton theory. You should really have initially all the glasses should have more benefit balance special device, and then before you can combine all the features together. You start up simple, more function oriented, more benefit oriented, and then you merge them at the end. So I must have to repeat again. You start with the eyeglasses. We now know it had to be eyeglasses. That's the basic hardware platform. Then you put in different benefits, and one at a time. And with time, all these things can be converged into one. So with that, I would say this. The wearable evolution path is actually very messy. It has taken us a long time. Finally, we now see a clear path. How are you going to do it? You started with the eyeglasses, started with the voice, then you put it into vision, put it in the display. And the display had to be very tiny, micro display, and somehow we had to magnify the image to your eyes to use these special optics. So in the next seminar series section, I will actually describe some of the current headsets and glasses that are now much more widely accepted. We will analyze the pros and cons of those glasses, and from there, we can actually learn and actually get a lot of hints what the next session should be, how to go to the final climb to the summit. So in 15 years, I think we can go faster than that, but I think certainly in 15 years, we will have the glass that we want, that we'll be dreaming about at the beginning of my talk, that allow you not only combine many devices into one, move the cell phones, smartphones into a smart glass, will also make you into superhumans and also give you a wonderful fantasy world. So this is in 15 years, we will get there. Thank you very much for the first section. Thank you. With
Thank
that,
you,
I think
Jim.
we should join us for the second one, where we will actually look at what do we have now what kind of glasses are coming out, and therefore that we will get our visions met in a few years. Thank you.
Thank you, John. I appreciate that. Very nicely done. So we have some time for some Q&A for you, the attendees. You should have a question box on your controls panel that allows you to enter some questions here that I can see and read them back to John. So while you're thinking about that, let me start off with a couple of questions for him. So, John, you've got a long history in the defense industry here. So a lot of products have started in development, either with R&D in the defense sector, and then moved more into enterprise and commercial applications, and finally into consumer. Is that the right path for AR and VR? Is that happening today? What's your opinion on that?
Thank you very much, Chris. It was a wonderful question. Yeah, I think all of us wish that we do not have to go through that path, go to defense and then enterprise and then consumer. It so happened in the smart glasses, it seems to be it is the path to follow. However, having said that, each of them have special characteristics. And certainly in the next session, I will describe the difference. In the military world, the technology is most important because it saves life. In the enterprise, is productivity is most important. So it is a different kind of system. Some of the characteristics are still the same, but some of the emphasis will be different. In the consumer world, it's really in many ways convenience and user experience are very important. So there, and of course, cost is all different. In the military, is really anything to achieve the technology. And as consumer world is a cost. But anyway, the technology that developed the military oftentimes move all the way down to consumer with time. As you remember, we started DARPANET. That I actually was working with DARPANET in MIT days in the 80s, and then yet in 10, 15 years, DARPANET turned to internet, everybody using it. So I think it's going to happen the same way.
Okay, great. Let's see. Patrick notes a question here. He says, heterojunction bipolar transistors, HBT, is a technology Kopin pioneered in the past. The HBT transformation started with Qualcomm, who was looking for a breakthrough to get them from the cell phone to the smartphone. Kopin answered by selling its HBT IP and focused on AR and VR. So what lessons have you learned from that experience to aid in a strategy for the AR and VR markets? And yes, will history repeat?
Oh, so this is a tough question. But I jump to the ending first. History will repeat. History always repeat. So that part is easy. Now, second part is actually we really talk about HBT, which I mentioned a little bit earlier in the talk. It's a very innovative transistor that we actually created, and that allow you to get very linear performance, which allow an analog phone go to a digital phone. The second thing you can do is very low power, so allow you to get a portable phone without having to tether to a battery. So the battery can be very small, and these are fundamental breakthrough that in many ways enable smartphones. And remember, the Qualcomm was our partner. Qualcomm is trying to advocate using a CDMA into a smartphone, and they succeeded. And we were for many years sole source to connection, and which later on turned into Skywork. And we were in everybody's phone for all these years. Now, what happened to the wearable smart glass? I think that there's two things very important. One is voice. As I told you, voice is the interface. The second is micro screen, small little micro display. And Kopin has been work on both of them, voice and microscreen. Microscreen is what DARPA always knew that we need. That's why they fund us $50 million to develop the microscreen. Currently, Kopin actually provide microscreens to all the technology of microscreen. Kopin actually is providing it or was working on it. So we hope the microscreen and voice are the equivalent of HBTs to allow the history to repeat.
I guess we'll have to stay tuned for the next webinars to get a little bit more insight into that opportunity, perhaps. Okay, let me turn to some of the audience questions here. Just give me a second to scan through these, if you will, please. Let's see. Nino asks, John, you point to audio as the input. Have you considered eye tracking as the future of smart glasses UI?
Yeah, I think everybody has been in the last 10, 15 years struggling, but what's the input and output? I didn't really have time at the time to analyze what happened to the IBM eyewear that they built right after we developed the microscreen. It was working. The only trouble is that we actually IBM as Kopin, we decided this is not it because when we wear the eyewear, the input is done by a little controller in the hand. So we have to control the input output, control the input in fact, and that is not hands free. So therefore, IBM say this is not good. It's not hands free. Now, of course, people say, okay, how do we give the input output, especially the input? Some people say, well, can I rotate the eyes to move the thing? Well, can you the eyes become the mouse, the hand mouse? I don't know whether a human like to use eyes as a mouse. I have difficulty to understand that. The second thing is, can you use your hand as a mouse? So you wave your hands all over the place to navigate. Maybe some people can do it, but it's difficult to imagine you will, in a public, move your hands to navigate the input. So I still think voice, right now, if you look at careful about the Apple Watch, Apple did a wonderful job. So they actually have three ways to give it to you. If a tiny little screen, micro screen, give you the output, okay? Have voice could give input and input and output, and it has a little touch. The little touch is really very simple touch. So I think in the eyewear, it's going to be like this. You will have voice, you still have a simple touch coupled with a micro screen. Exactly like what Apple Watch is. It says move on to your eyeglasses and it's hands-free and it's much more convenient to use.
Okay. So maybe eye tracking more useful for image enhancement, but not necessarily as a UI.
Yeah, you cannot you cannot replace the mouse.
Right, right. Plus, there's no accepted methodology for gesture control, right? I mean,
Yeah.
swipe may mean something to different people, right? So that's an issue.
Well, I think Hollywood, you see sometimes in the movies, people waving their hands to move things around. Some simple minor one you can do it, but I just can't consider that hand waving will not replace the mouse either.
True.
I think the Apple Watch is a very good example of what they have done. It's a wonderful idea.
Okay. Moving on, Gordon asks, is it not difficult to use voice in busy social situations as an input system?
Wow. Thank you, Gordon. I don't know who you are, but this is a wonderful lead-in by question. Yeah, it is an issue. In fact, almost 15 years ago, when I was talking to people in Japan, and Japanese, as you well know, good friends of mine, they all say, but we don't like to talk loud in the public. So that's why Kopin's voice technology is actually trademark. It's called whisper. So we want to whisper to use the example. So yeah, you don't say it loud. You whisper to it, and yeah, you can in some way, our technologies allow you to kind of a very low voice to go through as interface. But still, yeah, you're right. That's why you still have a little touch screen in there, touch space. As you well know, in some of the, in fact, I will talk about in the next section, how a platform will look like. You do have a little touch. In the case where you're not convenient to use a voice, use touch.
Okay, David asks, what were the problems with the smart glasses from Google?
Is another interesting question. As you well know, our display systems is in Google Glass 1 as well as Google Glass 2. Now, one of the first things we find out is that remember our basic rule 1 is human first, technology second. The Google Glass is not a glass. It doesn't look fashionable at all. It sticks out. All our earliest versions are the same way. Now, for enterprise world, people can live with it. I may want to live with it, but consumer is not going to walk around with something that looks very funny and odd shape. Fashionable is very important. So I think this is the probably most important problem in all our glasses. The glass should look fashionable, looks ordinary, looks regular. So there's a lot of question about Google as cameras and other stuff. No, I think the biggest problem is it doesn't look like a regular eyeglasses.
Yeah. Plus, it had a camera, which was
Yeah,
an issue
I
too.
think yeah, camera itself is a privacy issue.
Yeah.
But we have cameras in the cell phone also,
Yeah.
smartphone,
True.
and I think that can be overcome. But it's difficult for overcoming if it not look doesn't look good. It's not comfortable to wear. Then I think it's a big problem.
Yeah. True. Let's see. Ajay Kumar says, John, a comment. I think your rule number 3 is the most critical. Also, I think must have has to be identified correctly, cannot be a nice to have.
Yeah, I think you're right, especially in the go back to the Clayton's criticism theory. When you go to hands-free, the initial set of the devices should be very pointed to different functions. And in order to get these functions, the must-have is much easier for people to adopt. The reason we're wearing eyeglasses, that 40% of people wear eyeglasses because they correct our visions. As you say, people don't want to wear things on your head, but you wear the eyeglasses to fix your vision, or you wear a hat in order to protect yourself in a football game, or to keep yourself warm. So yeah, must have is very important, but nice to have doesn't mean that you don't want to have it. Once you have must have, then you can put things nice to have. So must have first and the nice have later. Yeah, I think it's a good question. It's a good point. Yeah.
Okay. Moving on, Florence says, which product are you most proud of during those 3 decades?
Most proud.
You have so many children. Which is your favorite?
I think that each one, I never thought about it. I mean, like you say, you will have 30 children, which is the most favorable. They all have different characteristics. If you want to watch a movie, actually, it's a very interesting world. I think I would like to say everybody like to have a dream. Everybody have dreams. The fantasy world is actually very important. We need dreams. It's not like nice to have. We must have dreams. And the reason we read books, the reason we watch TV, is actually is put us into a fantasy world. So I think the video glasses that Olympus put together and are way ahead of schedule. but it is what eventually people will have a consumer will. Another thing is the must-have is like, can you see in the dark? Sure,
Mm.
you would like to see in the dark, right? Can you correct your vision? Suppose your eyes are even your eyeglass lenses cannot correct you. Sure. Can you fix your hearings? I think the people, there are some glasses or some headsets try to correct their hearing. But why all those things are must have. Now go back to which device I like most. Well, I'm going to be biased. I like actually like Solos that was put out 3 years ago most, but it was still too complicated, and it still not look like a regular glass. So it need to be fixed. We'll talk about that in the second session.
Okay, no more Sophie's Choice questions now.
Yeah.
Okay, Derek asks, how was your experience supporting development of the F-35 optical see-through AR helmet, shaping your AR optical development activity?
Wow. You actually gave from the lead in for my second session.
That's true.
In the second session here, in the first session, I did not talk too much about what happened in the military world. In the second session, we will discuss a couple of military systems that actually give us a very clear path what the future will look like. F-35 is an incredible helmet. It is in fact the smart glass I show you at the end, except that it's 100 times bigger, 1,000 times more expensive. The question is, in 15 years, can we take the whole thing down to that glass that I will talk about in 15 years and bring the price down by 1,000 times and bring the size down by maybe 1,000 times? But many of the optics, the systems, the display, the thing they can do, the benefits that allow you to see around the whole airplane, allow you to see in the dark, allow you to see in the sunlight, bright sunlight, are there. So I will actually spend maybe 5 minutes or so in the second session, actually discuss that to the things that we're allowed to talk about. I will talk about it. And actually, if you look at it, you say, wow, the answer is right there.
Okay. Let's see. Moving on. We still got a little time left. Dirk asks, what have been the most critical technical challenges which have been managed in the past on the journey to the current AR glasses generation? And what do you expect to be the upcoming most critical challenges toward the future of AR glasses?
Yeah, I think the first most critical thing when we were doing it 30 years ago, and thanks to DARPA, they were right. The first thing you need a very, very small micro screen together with the optics. And we spent many years, many activities. So in the process, about 5 to 10 years after the DARPA activities, we recognize actually voice is the most critical at the beginning. So we actually spent 10 years, Copen spent 10 years develop that voice technology. I think also thanks to everybody, you know, the voice search, voice recognition is very, very advanced now because of cell phone. If you really think about it, the cell phone actually developed a lot of technologies and components are needed that are needed in the smart glass, including the voice,
Yep.
right? Including the voice. What is missing is the cell phone, cell phone do not have the micro screen and do not have the optics. So I would say in the next section and the third, certainly the last section, we talk about how to develop these micro screens, how to develop the optics to allow you to put on the eyeglass without you actually notice it. That's the toughest part. You can put a micro screen in there, like people do in the enterprise, but people can see it. You want it to bury inside the eyeglass, people will not see that you are actually looking at it. So that is the toughest challenge, and we'll talk about that in the section 2 and 3 on that.
Okay.
So that we could describe that. Yeah.
Okay. So let me keep reading some of these here. Sorry. Richard asks, can you please share? Can you please share? Wait a second. There we go. Sorry. Can you please share what you think Copeland's competitive advantage might be relative to others in the AR VR marketplace?
Okay, so my talk, of course, is not trying to be totally coping centric, but since the question comes out, I think that go back again, the platform to build it is you got to be an eyeglass, and you also got to have voice. It also have micro screen. Now on the micro screen, again, thanks to DARPA, we started 30 years ago. We started how to build a micro screen. Remember, the small screen, the display, it's not the one that you use for your TV. It's not the same display that you use for your cell phone. Okay, all these things were done on glass. Once you go to micro screen, we believe that it had to be done on silicon. The ICs, the electronics, actually embedded and married together with a screen. Kopin started this with DARPA. DARPA always say the day one, they want the LCD screen for the wearable based on silicon wafers. We're the only one in the world to start that. And currently, all the military systems, microscreens, are all on silicon, LCD. So now we are now leading in the microscreens of all micro on silicon. And eventually, of course, we already announced it, we'll also do micro LEDs on silicon. All our displays on silicon, and this is our competitive advantage. Everything should be on silicon. Do not think about micro screen on glass.
Got it. So John says, vision changes through the human lifespan. Technology is expensive. Can we accommodate corrective lens changes in smart glasses?
Could you repeat this question? I try to.
So he basically wants to know if you can accommodate corrective optics in the glasses to accommodate for your changes in your human vision over time.
The answer is, of course, yes. I think the lens, which Kopin is now working on it, the lens can be adjusted electronically, I'm sure. So also can make it darker, make correct visions on the lens. And that people are working on it, and I think there's a wonderful area to do it. Kopin doesn't have any competitive advantage there. We hope other people will develop. Yeah.
Yeah. Okay.
It is a very important area. Yeah.
Yes. Yeah, indeed. Let's see. Yeah, so here's a comment coming back to the Google Glass. A couple of issues. One, privacy, people being recorded, which we talked a bit about. Overhyped use cases. Street use was overhyped. Lots and lots of back-end processing needed for this. It's mostly a comment. I'm not sure you need to say anything additional on that.
Yeah, I think since the question and comment came out, I might make a comment, which I was intended to do that anyway on the session 2 and 3.
Yeah.
The AR glasses, the way the Hollywood wants us to believe, is not necessarily could be accepted by the consumer that easily. Our cognitive brain will not be able to absorb this data flash in front of your eyes all the time when you're walking around.
Yeah.
And that is something that we will talk more about in the next session.
Okay. So Christopher asks, have you seen a sci-fi movie with AR or VR products that particularly inspires you? If so, which one?
I I personally, if you ask me today, what between AR and VR, which is itself is a the definition need to be changed anyway, but the conventionally the VR glass to me is more at this point for consumer is more useful at this point. For the enterprise world and perhaps even for military world, AI is more important. For the consumer world, I think the near term VR is more important.
Okay, but there's not a particular movie that you've seen that it was inspiring to any of those visions, was the question.
No, I'm gonna I I I'm not gonna promote any movies here.
Okay, all right. Here's a competitive question. Dirk says, how do you see the future of different microdisplay technologies, i.e. LCD, OLED, LCOS, micro LED, with respect to AR?
Okay. Again, we're going to describe that in the session 2, especially in session 3,
Yeah,
which technology is cool for what applications. My feeling is, as you well know, we actually coping does all three. We do micro LCD on silicon, we do micro OLED on silicon,
yeah,
and we already announced we do micro LED on silicon. So we probably the first, but probably the only one today are the most neutral or partly the same. I think micro LCD right now are almost all use primarily or more the military system using micro LCD right now.
yeah.
They are thinking about and in fact working on with us to move it to micro or OLED for some applications. On enterprise, right now, most of them are also micro LCDs. Again, they're thinking about going to micro OLEDs. In the air, the ultimate display could very well be micro LEDs, which give it the brightest one for some brightest applications. Military would like that first, but that is 3, 5, 10 years away.
Yeah.
So right now, practical ones, LCD, micro OLED is coming soon, and then micro LED, yeah, you should work on it, but don't expect anything in the next 5 years.
Okay. Leslie asks, have you had any significant learnings from the Army's use of night vision goggles that will be relevant for the industry going forward?
The answer is yes. In fact, again, we'll describe in the session 2 how in the night visions, how the night vision goggles, how the night vision gun sights is using the AR, how the optics work, and how the display works. And it's not that that you will make you a better soldier only. I actually think many of the technology they used can be used for consumer. I think I always felt that I always like to be able to see the dark. Uh, I don't know whether I want to see around the corner or not, but I want to be able to see the dark. And the
Indeed.
night vision allow you to do that. And I think that is not that far away. If you want it, you can get it pretty soon. And also, you can correct your visions. As we get older, our eyes are not as sensitive. We cannot see in the dark ourselves now. And so all these things can be corrected. Hearing is the same way. The smart glass will be able to correct your hearing. So therefore, so you again you merge the hearing aid into a smart glass.
Hmm. Yeah.
Okay, you merge your night vision goggle into a smart glass. So that's a different platform now. As I say in the beginning, it is much bigger than a cell phone. This business, this smart glass will be much bigger than smartphones. Smartphones will go in there, but the AR glass, VR glass we're talking about is really a subset of what we're doing.
Hmm.
This is really a subset. It's much bigger than that. We're going to have a digital eyeballs. We have digital ears. Things that you You cannot imagine. Your eyeballs, your ears will be very different. So it is all through engineering. It's not by life science. We're not going to change your genetic makeup because it takes too long anyway, and I'm not sure you're allowed to do that. But our engineering, let's say I'm an engineer at heart, we use engineering science to provide and make you superhumans.
Let's see, moving down the comments here and questions. Both Pierre and John pushed back a little bit on your voice interface, noting that they think it's failed in computers and it won't necessarily work in VR. There's social resistance. Sounds are hard um, to filter in a noisy environment. So how do you respond to that?
Yeah, that's a very, very good question. And again, I will describe that a smart audio glass that come out that's already in the market to answer many of the questions they have.
Hmm.
The privacy issues, the noise issues, they were all there. They were all there in the beginning.
Yep.
But many of the things are gone. The technology resolved. Okay, so we will talk about. In fact, I could fast forward 2 weeks. Other than we talk about the F-35 and night vision goggle, night vision gun size goggles, we're going to talk about a smart Solos glass.
Yep.
That's very much like that, and delete them or eliminate or minimize many of the things you're talking about. The question is talking about. So stay tuned for the second session where we talk about the present. That will
Okay.
actually solve quite a lot of voice issues. So therefore, the third session is talk about the vision. How do you describe? How do you develop the display and optics? So I think the voice is almost done. The second session is to describe what the present technology is. I think the voice platform is done. Now we have to put a display platform into the glass on the third
Okay.
session.
Okay. All right. So maybe the message is go out and try the latest voice glasses. Let's see where the state of the art is, perhaps.
Yeah, exactly. I think the voice question, many of the questions that people are tackling for the last 10 years of the voice are minimized or deleted now, eliminated with a
Okay.
new product. So I would say voice is here. And then the next one is what kind of display you put in there so that you cannot tell it is in there.
Gotcha. Okay. So continuing on this voice theme here, Francis says, do smart glasses need to have an open source movement for voice options? Leaders in speech like Amazon, Google, and now Microsoft with Nuance acquisition need to be available on all platforms.
That is going beyond technology, going to policies. Uh, my own feeling is there way to do the hardware platform for smart glass without get involved with which particular voice technology people use. Remember, the voice technology comes to two things. Once you voice, what we need to the smart glasses, take the voice into digital and transmit to the base stations or servers, AIs, and the background.
Yep.
And which background you use is transparent to you. All you need to do the glasses, take your voice, convert it into digital, and transmit. So in that case, it's not a matter of open source or closed source. It's just a matter of time. I will actually plot this out the next view graph, the next session, how the voice, which is used analog, how is developed into a digital voice and digital data and transmit all over the world and then convert it back to analog to your ears.
Okay.
And inside in the middle is not what we're involved with. It could be open source, closed source, many sources.
Gotcha. Okay. Well, we are at the top of the hour, so I do want to close this out. There's still many more questions, but many of them are still along the same things with themes we've been talking about. So why don't we end this here? As I said in the beginning, we will record this so others can come back and look at this who were not available here, or if you really want a review session. But thank you, John. Appreciate the insights, and we will do this again in 2 weeks.
Yeah, I think many of the questions will be answered in the second section or third. People still have a chance to ask their
Yeah,
questions.
exactly.
Thank you very much. Yeah,
Okay. Thank you
thank you.
all.
Bye bye. Yeah.
Bye.